My research is looking at biomass energy with carbon capture and storage. So the idea behind that is that you can take biomass, which are plants grown absorbing CO2 from the atmosphere via photosynthesis. You can then burn those in an energy conversion facility, capture the CO2 and transport it and store it underground in a geological formation. And if you can do that, in principle, you can remove CO2 from the atmosphere, and this is sometimes called negative emissions. So my research is looking around the challenges and assumptions around delivering biomass energy with carbon capture and storage. So this is used as a way to tackle climate change. We had an agreement in Paris in 2015 to try and limit our global average emission increase to 1.5 degrees. That's a very, very tight target. We're already approaching 1 degrees increase in temperature. So to do that, we need to massively reduce our carbon dioxide emissions and other greenhouse gas emissions. And that's going to be a very big implication to our energy systems, to our whole way of life, how we generate energy, how we use energy, how much energy we use. And it's going to be really, really difficult to reduce our emissions on a scale that's great enough to bring ourselves down to 1.5 degrees. If we can develop a methodology or an approach that will reduce those emissions further, it brings us into negative territory where we're actually taking CO2 out of the atmosphere, then that makes that task slightly easier or even feasible. It wouldn't be an alternative to mitigating our emissions or removing our emissions, but it might help us along the way with some of those very difficult sectors that are very difficult to abate. So I think the key take-home messages of the research that we've been doing is really looking at those challenges, and that a lot of those challenges are not technical necessarily. The engineering for this is fairly straightforward. There's ways of resolving the engineering challenges, but there's much bigger challenges that would have to be done to deliver this sort of negative emissions on a scale that could have an impact of the scale that we're talking about. And those are social issues, how we implement these technologies, the people on the ground that are involved in that, how we develop the policy frameworks and the governance frameworks for these big global supply chains that might be involved. So in terms of policy, I think it's very clear that there's no incentives at the moment to start developing this technology. We've been talking about carbon capture and storage for nearly 20 years now. We've known how to do it, but because it doesn't deliver anything in itself beyond carbon reductions, until there's an incentive to reduce our carbon emissions, these technologies are not going to get off the ground. There's a lot of talk about them, but until we have proper policy frameworks and proper incentives to make a very big reduction in our carbon emissions, it's very difficult to see how these technologies can ever be deployed. So one of the things that we're trying to do is to try and work with stakeholders and work with members of the public to look at how these technologies will affect them, but also to learn from the experience of different stakeholders, of different the farmers that might be responsible for delivering the biomass, the people that will make these chains happen. We're trying to work with them to understand and gain from their expertise and look at the best questions to ask around this technology and where the challenges can be met and how we can best address those challenges.